Hi, welcome to Pre-Calculus. Today's topic is writing a complex number in trigonometric form, the case of special angles. So I just want to remind you of these 5 pictures that are equivalent to each other. We are going to come back to these pictures to explain the question itself. So here's a question. Here's a complex number z is equal to 2 radical 3 minus 2i. Write it in trigonometric form. So what does that mean? This format is given, the standard form is given, a number plus another number times I. We want to write it in the trigonometric form, we want to write it in this form as a radius times cosine of an angle plus I sine of an angle. How about that angle? It's a special angle, one of the famous angles, and it's supposed to be, the requirement of the problem is that it has to be between 0 and 2 pi. So here is the problem. Best thing to do is to graph this thing to get an idea of what we are after. So if your graph is reasonably accurate, you already have your answer in front of you. 2 radical 3. So 2 radical 3, so suppose this is 1 and 2 and 3. 2 radical 3 will be almost 3.4 minus 2i. Minus 2i means step 1 in the lower direction, and this is step 2. So this is the location 2 radical 3 minus 2i. We want to express this thing in the trigonometric form, which is a radius times sine and cosine of an angle. What is the radius? This is the radius we are after. This is r. What angle do we want? We want angle between 0 and 2 pi, so we are forced to go in this direction. That's angle theta we are after. It's easier to think about this negative angle, but the format that we are asked for is between 0 and 2 pi. Well, how do we go back and forth? Remember, we have these conversion formulas. So r squared is, so if I have z is equal to a plus bi, my r squared is a squared plus b squared. Just the Pythagorean formula we are applying in this triangle, where this is my a and this is my b. So r squared is 2 radical 3 squared, and b is minus 2 squared, and 4 times 3 is 12. Minus 2 squared, remember, is positive. It becomes 16, so my r is going to be 4. It is also assumed, here doesn't say it, but we want positive r here. So minus 4 is excluded. How about tangent of theta? We have tangent of theta is equal to b over a. So in this case, my b is minus 2, and my a is 2 radical 3. And when I simplify 2's cancel, I multiply by radical 3. It's minus radical 3 over 3. So this tangent, we can solve it by calculator or by remember it by memory. This is, of course, or look at our table. This is minus 30 degrees, but we want it in a positive direction. So theta, we can first start with minus 30, but we want it in positive, but it's 330. We want it in radians as well. So what radians is that? So in radians, it's going to be 2 pi minus pi 6, which is 11 pi 6. So that is what is expected from us. So r is equal to 4 cosine of 11 pi 6. These two boxes always same, 11 pi 6. That is what is required. Here 5 minus 5 radical 3. So again, we're similar to the setup that we had up there. We are going 5, and then we are going down 5 radical 3, and then we are arriving at this location. So r squared is 5 squared plus minus 5, radical 3 squared. So 25 times 3 is 75, adds up to 100, or we take a positive root. So this is 10. How about this angle? Obviously, reference angle is 60 degrees, that's pi third, and 2 pi minus pi third is going to be 5, going this way. This is going to be 5 pi third, or look it up. So you can say tangent of theta again is minus radical 3. Would say theta is minus 60 degrees, or minus pi third, but we want it between 0 and 2 pi. So 2 pi minus pi third, it becomes 5 pi third. So here our answer is 10 cosine of 5 pi third and sine of 5 pi third here, and so on. So 5i, that would be extremely simple. Where is 5i? 5i is right here. So 5i, the distance is 5, and the angle you're going is pi over 2, so we don't need to do any calculations. It's 5 cosine of pi over 2, which is 0, sine of pi over 2, which is 1, and then you get 5i. How about minus 5i? Very similar to what we just had. Minus 5i, you will be down here. The angle you want, again, we are going in this direction, so the angle is 3 pi over 2. So distance again is 5 cosine of 3 pi over 2, sine of 3 pi over 2, and yes, that's the last one. Okay, so the problems were straightforward. Again, we are going back and forth between these formats, especially these two. We're going back and forth between these two intersections, and the important conversion formulas are these transformation formulas between Cartesian and polar. Okay, so until next time, good luck and God bless.